Oh, welcome. This is a nice experience being able to speak in a cinema. I've never been to such one, I've always been there, so it feels good. As you can notice from my accent, I'm from Argentina. My name is Matías Wolowski, and I'm here with Martin. We are going to talk about this nice topic called Death to Cookies and Long-Life Json Web Tokens. We're going to hang some cookies. This is my handler in Twitter, at Wolowski. If you follow me, I speak about crypto and other random things, put some pictures of nice places I go. And I'm the CTO and founder of Auth0. Auth0 is a company that helps with authentication, authorization, and single sign-on. We basically have an API that you plug your applications to, and we take care of all those details. So we are kind of been in this space of security, authentication, and authorization for a long time. And this is something that we've been working on heavily. This talk is not about, of course, it's not about the product. It's about something more, it's a standard that we are going to talk about. It's called Json Web Tokens. So don't go away. It's not about a product. It's about something that you can use on your applications today. And most of that, things that we are going to show is open source stuff, okay? A little warning, since we are here in a nice cinema, is this session is heavily live coding oriented. I don't know if you guys like that or not. I love when I go to a session and people just type code and explain from scratch how things work. So we decided to do that with Gonto here, my friend. So I hope you like it. And we'll do a little bit of, it's separated in two pieces. So first, we are going to talk about a little bit of theory of why Json Web Tokens are like a good architecture for authentication, how they are compared to cookies, and how they can be used in, I would say, more than modern applications, I would say modern systems. So our systems today have evolved to a different set of components and architectures that kind of changed from 10 years ago, right? So we are going to talk about that, and we also will be showing a couple of libraries that we open source, that we created. In particular, our AngularJs related libraries that helps you deal with this type of architecture on authentication. One is Angular Storage, the other one is Angular JWT, and the last one is JWT Decode, helps you decode tokens on the client side. So with that, I'm going to give you a quick overview of history of web applications and how we've been authenticating applications. So as you know, most of you have been doing in the last 10 years or even more. Applications are composed of, especially web applications, are composed of a web server and then some type of client that consumes applications pages that are served by this web server using the HTTP protocol. So the typical interaction starts with someone that types a username and password, and that's a post to a web server. The web server will authenticate that user and validates that the password is valid, and it will send back. So there is some more details in it, but in a nutshell, there will be a session that is going to be created on the server, and that session will be stored depending on the provider and the framework that you use in memory or in a cluster of databases or whatnot. And we get back a session ID and a header that says set cookie, and with the session ID and the value, right? From then on, subsequent requests will have this cookie sent on each of the requests. And what happens on the server is that the session is rehydrated from the whatever memory store or database you're using, and then you have the user authenticated, right? So this is how we've been doing stuff for the last decade or so. And there is nothing wrong about it, and we will keep using this. The reality is that there are a couple of things that changed in the in the way that we build applications, that we build systems, and not just only applications. And just to give you examples of, like, just let's introduce another thing into this architecture. So we had just a browser and web server, but now we are building applications that consist of also like a chat, for instance, or like it's just a real-time notification of, someone is doing something and you want to notify someone else that there is someone doing something, right? So that requires some kind of socket mechanism, like WebSockets or Socket.io in Node.js. It's a framework to do that, or in other frameworks there are other alternatives. But you get the point. The thing is, this new component has a new or a different way of authenticating the user session. So the user logged into the web server, to this web server. In this case, I put there PHP. It could be anything. And maybe the other component, which is using Socket.io and Node.js, it's a complete different technology, complete different stack, complete different set of components used to authenticate the user. So now I need to find a way of authenticate that user in the second component, this socket, right? So it's something that is not easy. Actually, I have a good story about this same scenario. So there is a company, and this is a very common scenario. So you start using there was a company who has an application, big application built on Java, and they wanted to move to Node.js. And of course, as any migration, you don't just turn off a switch and turn on the other, because that doesn't work in the real world. You usually start moving away some pieces, and then at some point, you have all the pieces moved, and you're finally migrated. And again, you have to deal with authentication in that scenario as well, right? So the user start maybe in a Java part of application that wasn't migrated yet, and then moves to a Node.js part that has already been migrated. So how do you keep the session of the user across these two companies, these two technologies and stacks? It's basically a hard thing to do, because each of them uses a different set of ways of interpreting the session, the cookie, how to store the session, etc. So the bottom line of this is that if you want to start, if you live in the real world, you're mixing different type of components and different architectures and stacks. And the cookies are coupled to the web frameworks that you're using. So in essence, it's an architecture that is like, it creates coupling. And it's not an elegant solution in that sense, right? The second thing is that nowadays we build more and more applications that are not only just web-based. The same applications that we have web-based front-end, we also have a phone. We're consuming it from a native iOS application, or like a Titanium, or we build maybe a Mac OS application for that same backend, and suddenly we have the notion of APIs. So it's not anymore just a web page that goes and refresh every time that you do an interaction from the browser, but it's about creating APIs that serve certain purposes, and we create front ends that consume those APIs. And in that architecture, again, the same thing happens. So APIs usually don't use cookies. Have you seen an API that has a cookie, like ask for a cookie? No, you usually don't. So what you do, in this sense, is, again, you're creating another silo or another mechanism to flow the identity of the user in this case. You have to find a way of doing it from the phone in one way, and then from the web page in another way, and then from the Socket.io server in another way. So you start creating multiple ways of authenticating a user. The last interesting part of this problem is that you usually want, so your systems are not composed of just a single API or a single web server, but usually want to separate things, different APIs that serve different purposes, and you want to make sure that the identity of the user flows from one component to the other. So if I call, let's say from a phone, I call a function that, for instance, I want to buy a ticket for a flight. So I buy it, I call, let's say there's an API that is supposed to book a flight, and then when that API calls another 3 other systems, another 3 APIs, and we want that the same user who calls that post to book the flight to be able to call those other APIs, and the identity of that user who originally called flows to these other components. If you ever have to do something like that, it usually requires some tokens and stuff that is not easy. And again, cookies in that sense don't work because basically they don't flow across the different layers. You use the cookie just for a web page. You cannot get the cookie and then send it to other thing and magically have the identity of the user flow from one place to the other. In addition to that, there is I put there like a box that says AWS S3. We are more and more using components that we don't own, right? In this case, AWS is another component that we could use to store, I don't know, blob storage or SQS or whatever. The thing is, again, this component is something that we don't own, hence there is another way of authenticating a user. Usually, you put something in the middle that handles the API keys for use, and it's like a proxy between your front end and that component. But what if we could consume this from our clients in a transparent way, and all these little things that we are using to build our applications can flow the identity of the user across all these components? That would be like an interesting architecture. Do you agree with me, right? So we are proposing here a better approach to that problem. And this approach is based on tokens, okay? And it's a very simple idea, actually. What you do is, instead of letting the cookies drive the whole authentication process, you own the process because you create the tokens yourself, and then you orchestrate or you move those tokens however you want. From layers, you store them whatever you want, and it's kind of something you own. It's not something that is owned by a framework. And in particular, we will talk about a standard called Json Web Tokens. This is a standard that has been around for, I think, May 2012. It was the first draft of the standard. It's the URL is there. Right now we are in the draft number 30. It's very soon it's going to be IETF, standard. These guys like to take time to go through these things. You might be familiar with that, with the JSF standards and that kind of things. The thing is, this standard is a very interesting one, and it's actually super simple, and I will show you how it works. And it will help you solve this problem in a much more elegant way. So with that, I will go to this website. Some of you might have seen it if you went to our booth in the expo area. But I will go through it again. Can make this is okay? Yeah, I think it's okay. So I would like to do a quick poll before showing this. How many of you heard of Json Web Tokens? Raise hand. Nice. So I think like 1/3 of the audience will have to hear again about this. Maybe you will learn a little bit more, but bear with me. So the Json Web Token, what you see here is a little page that we created. It's called jwt.io, and it's a debugger here. I use this as a tool to explain exactly what a Json Web Token is. You can, of course, read the standard, which is somewhere here. We are pointing to it. So if it loads, because it's a little bit long, I will wait. There you go. So this is a standard, okay? You can read this, I don't know, it's 34 pages, and then you will be a Json Web Token master. Okay? Or you can hear my 2 minutes how it works talk. Basically, it has 3 pieces. So the first one is a header. what I'm highlighting there. The second one is a payload. The third one is a signature. On the left side is encoded version. On the right side is a decoded version of the token. So you see in the header, the first piece, we say that this is a JWT, and it's signed with this algorithm, HMAC SHA-256. This is the first thing that is different when you use cookies. When you use a cookie, there is nothing that says what the cookie should look like. There is no standard for cookies, right? This token says, or this standard says that you can sign a token using this algorithm, HMAC SHA-256. Then you have the payload, and the payload is a set of properties, and this is where the JSON is. So Json Web Token is just a JSON that is digitally signed, or actually hashed. I can add more information here, so notice that this is a real-time thing, so if I add more stuff, I am breaking the JSON format, but if I keep adding, now it's coming up again, I keep adding stuff, I keep adding, and the token keeps growing as well. Another interesting property of the token is that it's completely stateless. You can put as much information as you want here, and as soon as it doesn't get super giant, well, it will be okay to send it through an HTTP header. So it's, again, it doesn't need any state on the server, as opposed to a cookie that, well, there are different solutions, but usually the default mechanisms of a cookie is that you get a session ID and you get a session stored somewhere in the server that is storing the actual content of the session. And you see that there is also, you have email here, you have the user ID and whatever you want. And finally, the signature. And the signature is calculated in a very simple way. So you do HMAC SHA-256, as the header was specifying. You do base64 URL encode of the header, which is basically the result of doing this thing here, running that base64 to this, and you get this. And then base64 URL encode of the payload, and you get this. You concatenate these two, and you run the HMAC algorithm with this secret, and you get this. So this is a signature. What that means is that if someone tries to validate this token with a secret that is not the one that we created the token with, if I change this, you see that this is invalid signature here. So what this does is it helps us with the tampering of the token. Someone touched the token there and tries to change, admin, and let's say it was false, and someone changes it to true. The token will not be valid because it will break the signature. Unless the hacker has the secret, it won't be able to do it. So that's like a super high-level overview of what the Json Web Token is. And I would like to highlight here that this standard has been picked up by the community pretty heavily. You have libraries in mostly every language out there, so .NET, Python, Node, Java, PHP, Ruby, Go, even JavaScript. So this tool that you see here is completely built using JavaScript. There is no server-side thing. So it's using Crypto.js itself. So with that, I finished with the chit-chat. I hope you could understand the concept. Now we're going to do a little bit more of an in-depth demonstration, the live coding thing that I told you before. So Gonto will be a demo of actually using this in a real JavaScript application with an API. Okay?
So, hey everyone, how are you? Are you guys ready for some live coding? Awesome.
So this is the developer advocate of Outside. You can sense the energy, right?
So right now what we're going to do is we're going to create a single page application that basically calls an API. And this single page app right now doesn't have authentication at all. So we're going to add authentication. So we actually have two versions of this live coding demo single page app. We have one which is with AngularJS, and we have another one which is with Browserify and regular jQuery. So I just want to know what you prefer to learn, like how to do it in AngularJS or how to do it with Vanilla.js and jQuery. So everybody who wants AngularJS, if you can put your hands up.
Wow.
Wow. Well, we'll do the single page app with jQuery then. Thank you. Okay, so we'll do the AngularJS one probably. So let's start with it. So right now, we already have a repository for this. It's in Auth0, it's AngularJs JWT authentication tutorial. And in here, it's separated in front-end and back-end. What you will see is I will go through step by step of how to add it. Each of these steps that I'm going to do is actually going to be a different branch in this repository. So you can just use these branches and navigate with me if you want right now, clone the project, and be seeing live in your code besides here what I'm doing. So now that we have this in mind, let's actually close the other one. And let's first start the server. The server right now is a Node.js server, but it could be Java, it could be PHP, it could be whatever. We're going to see mostly the front-end code. So let's start the server, and let's also start the front-end up to see what we have right now. So let's go here. So this is what we have right now. It's the Eng Europe example that I see. Sorry, I didn't edit it yet. But we have two buttons here. This is the main application that we have right now. And the two buttons, what they do is the first one calls an anonymous API. And what it does is it returns a new original Chuck Norris phrase every time you click it. So if I keep on clicking it, you can keep reading awesome Chuck Norris phrases. And if we click now the call secure API, what you will see is that you're not authorized to see it. So in the call anonymous API, we have 50 phrases. In the call secure, we have other 50 Chuck Norris phrases. So if we want to see the 100 Chuck Norris phrases, we need to learn how to add authentication with Json Web Tokens. And that's what we're going to do now. So the first thing that we can do is actually add then a sign-in page. So for that, let's kill this 1 second, and let's open Sublime. So let's see first the structure of the project really quickly. We have an index HTML. Is the font too big or is it okay? Okay? Good. So this is the basic index HTML. We have also the application JavaScript right now. And then we have each of the pages is a separate folder. So we have the home right now. And what we're going to do is add first the signup page. In the signup page right now, we have the HTML. Because I'm very bad with design and HTML and CSS, so I did another one with Bootstrap, of course, already, and we're going to be using it. And then we have the signup.js, which is empty. So what we're going to do first is to start this signup.js. How are we going to start it? We're going to do what every good programmer does, which is copy and paste. We're going to start with the home, copy all the code, paste it here, and then continue with this. So now, it was sample.com, so now we're going to do signup. And we're going to use a feature that I love from Sublime, which is multi-select. So this is the sign-up controller. I'm watching very good for typos because I'm very typo-friendly. I'll try not to do any typo right now. So then we're using UI router here. So we're going to define the sign-up URL. And in the sign-up controller, what we're going to do is not any of this. We're going to just call the sign-up API we have right now. What does the sign-up API does? Basically this. Let me, in really short, what it does is it receives the username and the password. It checks if the username and the password is sent. It checks that the user doesn't exist. And then based on that, this uses the JWT library for Node.js and creates a JSON Web Token based on that. If you were using Java, you could use Java JWT, which is also a library that we made, which lets you create JSON Web Tokens using Java. But for now, in this server, it's using Node.js, and the URL is /users. So what we're going to do is we're going to have a signup method, and this is just going to call $HTTP. So it will be to the URL, which is localhost 3001 users. The data that it's going to send is the user. We're going to load it in a second. And then the method is going to be post. And that's it. That's all we're going to send. And then once this successfully is done, we're going to add the response both in the error and in the case of success with the promise. And what we're going to do is if there's a success, we're going to save the JSON Web Token. How are we going to save the JSON Web Token? We've also created a library called Angular Storage, which is an easier way to store things with Angular. What it basically does is it uses local storage if it exists. Otherwise, it uses cookies if you're IE8 or older. And also, it lets you store objects. So we're going to add the dependency here to that Angular storage library. We're going to inject it here. And now we're going to use it. So in here, let's just store this JWT. And we get it from response.data.id token. And then once that's done, what we're going to do is redirect the user again to the home. So for that, we're going to use $state since this is UI router. We need to inject it as well. And then in the error, we're going to alert the message. So alert response.data. And with this, we have hopefully made a functional signup. Now all we need to do is create an empty object user here that we can bind from the view. And then in the HTML, let's add ng model everywhere. So user, this is going to be user.username. The password is going to be user.password. And then the extra information is going to be user.extra. And finally, when the user clicks on submit, we're going to do ng-click signup, I think I called it. And with this, we have finished implementation. So now we just need to add it here, the sample.signup, and that should be it. Of course, it won't work the first time, but let's hope. So now if I go to signup, let's see. It works. I'm amazed. So now we have the signup implemented. Don't applaud yet. We haven't tried it. It's just the UI for now. So now let's try to see if it works. I leave the console open because I don't have faith. So let's create, I don't know, mgonto, password, 1234, don't tell anyone, and extra. Now we're clicking on submit. And apparently it's working. Let's see if we have this saved in the local storage. And we have a token, apparently. So let's grab it. And let's see what this is. We're going to paste it here. And delete this. And what do we have here? We have the information that we have set in the token. So I have created a username mgonto. I've set the extra information to extra. I have the ID here. And the secret says invalid signature. Why? Because the secret that I'm using in the server is not secret. I'm not sure which one it is, but it's not secret, that's for sure. So now that we have this implemented, what we can do is, first, let's show the token somehow. So let's go to the home.js, and let's import here the store. And let's do $scope.jwt equals store.getJWT. No, I'm not buying you now. So refresh. And now we see the Json Web Token. Now what we can do is, we have created also another library called AngularJWT, which lets you decode this Json Web Token from Angular itself to get all the information, instead of going, because of course your user won't be copying it to JWT.io. So let's do that. Let's inject here the JWT helper. Let's add the AngularJWT module. And now, once we have this, let's add this $scope.decodedJWT equals, we're going to check if the JWT is here, and if it's here, we're going to do JWT helper.decode token $scope.jwt. Now that we have it here, let's just show it in the UI. So again, copy, paste. And instead of showing JWT, we're showing JWT, decoded JWT, sorry, JSON. Refresh. And now here we have the decoded JWT. This is a basic JSON object, and we can start using it.
So let me see if I understood, because all this ng craziness, it's a little bit hard to digest. But what you did is call the signup API that returned a JSON Web Token, and then compared to cookies, where cookies are just part of the browser that you just use to call every web page. What you did is you store that in local storage, and then you use that to call an API.
I haven't yet called an API, okay. So you're going forward. But
okay, sorry. And so you just get the token in the client. That's it.
Yeah, that's it. That's all we're doing. So let's ask you. Now, I have the JWT, so now I can call the secure API. What will the secure API answer? Will it work or fail? So hands up for work. Okay, you're following the conversation. It's pretty good. So now we call secure API, and it still doesn't work. Why it still doesn't work? Because even though we have the ID token, we're actually not sending it in the authorization header. So we need to send it. So how do we do that? We can use a $HTTP provider interceptor that sends it every time. For that, in the Angular JWT library that we created, we have also a JWT token interceptor provider, all those names, which basically sends the authorization header with the token. So what we're going to do is use that. So for that, we go to the application. In here, we're going to depend on Angular JWT and Angular storage. And then we're going to inject here the JWT interceptor provider and the $HTTP provider. And if I wrote all that correctly, now what we can do is JWT interceptor provider.token getter. And in this function, we need to specify how we can get the token to be sent. If we return null here, no authorization header is sent. If we return a token here, that token will be sent. So what we're going to do is we're going to get the store here and then just return what the store has. If the store doesn't have anything, it will just return null. So it will work. And now that we have configured this, we're going to add this to the list of interceptors that the $HTTP will have. And this is JWT interceptor. So now we try it again. Let's refresh the page. We call the secure API, and we have more Chuck Norris faces.
Yeah.
So now we can keep on clicking it. But what we're going to do now is let's try something else. Let's try actually to create a token, as he was saying, from here. So I'm going to be, let's say I'm going to be, instead of me, let's be Sean Doe. And we're going to sign it with the secret, I don't know, with this secret. So now we're copying it, and we're going to set this in local storage manually, just like if I've just logged in. So if I change it here, let's put it. Now we refresh the page. Now we can still see here the ID token. We can see here what I've just created, the Sean Doe. And what do you think that will happen if I call the secure API now? Will it work or not? Hands up for won't work? See, I did it the other way. Now you had to put the hands up. So now, if we call the secure API, it won't work, and it's saying invalid signature, which is exactly right, because the signature is invalid. And what this means is that having the user logged in doesn't really exist in a single-page app. In a regular web app, we check in a URL if the user is logged in or not in the session, and if he's not there in the session, we just redirect to another page. However, in this case here, the user is not logged in, and he can still see this page. Why? Because the user being logged in means a token in local storage. That's it. No session, no anything. So he's not really logged in. And now, if I actually delete this token, let's delete it from local storage and refresh, we don't see the token anymore shown, and we still get the error. And this is something that's not cool. Even though our API, our application is working correctly, because if the user is not logged in, he cannot do any operation in the server. He cannot do any operation in the server if he doesn't have the token. However, as this is a single-page app and HTML and JavaScript is available, he can still see this page. And we don't want that. So as we don't want him, what we're going to do is to forbid this via client-side. How can we do that? With a simple event that we can listen from UI router. So let's do that now. Let's come here to the app.js again, and let's add now a run method. In the run, we're going to get the root scope, $state, JWT helper. Basically, we're importing everything. Once we finish importing everything that we need, now we can listen to the event which is called $state change start. $state change start is called before the browser goes to a root with Angular. So before it goes to a root, we can say, no. The user can't go to that root. Redirect to another place. Even though that HTML, that JavaScript will be available to the client because it's the browser, everything is available, at least we're not showing it to him. So here what we're going to do is we're going to subscribe to that event, $state change start. Angular people likes a lot of money. I mean, everything is $, but well. In here we receive the event and the to. The to is the state to which we're moving forward. So what we're going to do here is to check if there's a token. How do we do that? We just get it via our store. And what we're going to do is, if there's no token, or if there is a token and it's expired, we can use for that JWT helper.isTokenExpired of this JWT. If this is what happens, we're going to say, no, don't go to that page, and go to the home. So in that case, we're saying, prevent defaults, so don't go to that page, and go to home. However, we don't want to check this for every page. We only want to check this for pages that need authentication, that needs the user to be logged in. So how do we do that? The state that he's going to, we can check there if he has added some information to say, okay, this state requires login. So we can do if 2.data and 2.data.requires login. This is any word that we can put. I can put requires token, requires login, whatever. The important is that when you declare this root, you add this word and set it to true, or set it to something that is truthy, so that it works. So in here, in this case, then, we're checking this. Otherwise, we're doing nothing. And with this, now, if we try it out, will it work? Hands up for it will work. Good. It won't work because we still need to add the requires login to true. So now we go to the home.js, and in here we have said the home page now requires the user to be logged in.
So you're defining in the router, in the roots, that this particular page requires the user to be logged in, and that means the user that needs to have the token in local storage.
Exactly, right? Because he's not really logged in. There is no session, there's nothing.
Cool.
However, this should be sign up. Yes. Typo. See?
Who said that? Who said that? You get a t-shirt.
Thank you.
You have one? Okay. Someone wants his t-shirt?
So now, let's refresh this. And it still doesn't work.
Well,
one error in all the presentation is pretty good, right?
We didn't finish yet.
Okay, so. Oh, yeah. Very good, thank you.
Who said that? Come back for a t-shirt.
So now let's refresh again.
You have it already?
And now it has gone to the sign up page. So again, we go here, we touch enter, and it goes to the sign up page. So let's sign up in this case. Let's do Sean. I'm very creative. And let's put, hey. We submit this. Now we get again this token, the information, etc. We refresh the page and it stays here. It doesn't send me to the sign up. And if I click here on call secure API, it still has an answer. So in these 25 minutes, we went from an application that had no login at all, but had an API that needed login, and we have added sign up. We could have added login, it's exactly the same, but calling another endpoint. And then we're storing the user information, and we're not allowing the user to get to a root that he doesn't have access to. He can see it if he views the source, but he can access it. So we have completed a single page application that works with authenticated users, doesn't use two cookies, use Json Web Tokens or tokens in general. So now I will leave you with Matthias again with a more complicated example about this, but I hope you liked it. Thank you.
Okay, I definitely need to work on my live coding skills so I can get some applause as well. But anyway, I will show you a little bit more complex example. And this one in particular is around using Touch ID for authentication. And the idea of this is showing how you can use Json Web Tokens in another complete different scenario to implement Touch ID authentication in a mobile application. So you know Touch ID is the new thing from Apple, that you can put your finger and then you can pay with your credit card and whatnot. Probably the world will be run by fingerprints, so take care of so nobody cuts your finger. But the thing is, it's a convenient way of kind of proving that we are who we are, right? And what I will show you first is how it works. If the camera can, let's see. This will be.
You can move a little bit closer, maybe.
Let's see. Of course, we had Reflector, just an app that can stream the phone to the computer, but it didn't work.
It looks like a very nice white screen.
Yeah. Does it work, or it's too much light? Okay, I think that works.
Yeah.
So you see that it says login with Touch ID, and then you see the finger there. I touch here, and it asks me for enter the Touch ID, my finger, or the passcode. I will put my finger here, and you see it's logging in. And in this case, what it's doing, it's going against, so it's creating a set of private and public key. And of course, this one will take some time. It's going to a server and going back and whatnot.
You have Wi-Fi?
Yeah, I think so. Anyway, you will get the idea. I will explain how it works in detail.
You don't get applause because my example works
there you go,
better.
there. Yeah, you can applause now, okay? So, you see that there is a JWT at the beginning of the screen. This is just debug information. And there is a public key and a private key here. So I will explain how this works and how Json Web Tokens can be used in this scenario as well. So the way we did this is, first we ask the user to log in with Touch ID. When we do that, the way Touch ID works is, actually it's, what it does is it protects the keychain. So the Touch ID thing, when you touch it, what it does is allow you to access a certain key in the keychain. The iOS keychain is something that is protected, of course. It has all your passwords that you use for any application and whatnot. So everything that you can store secretly, you use a keychain. The Touch ID is just a simple mechanism to unlock a key from the chain, from the keychain. So what we do is we ask for the finger. We read the keychain to see if there is already a private key in the keychain or not. And if there is no private key generated already, since the user never kind of logged in for the first time in the phone, we generate a key pair using iOS APIs. You generate like a private and public key pair using RSA crypto, and you store it, and we store it in the keychain, right? The next thing that we do is we call a server and we send the public piece of the key, so that the server knows that kind of this is a new public key that you have to accept from now on, right? Then what we do is we generate the Json Web Token using the private key that was generated that I have in my phone, and we sign it with that private key. Okay, so it means compared to what we showed before, we were using what is called a symmetric key. The same secret is used for whoever produces the token, and the same key is used for whoever consumes the token. So usually it has to be the same person, the same system. You know? The server produces a token with a secret, and then the server validates the token with the same secret. That's a shared, 101 crypto symmetric keys. In this case, the one who is generating the token is the phone. It's not the server. We are generating a Json Web Token, signing it with a private key that we have on the phone, right? So since the private key is mine, you can think of this as an SSH, right? The SSH key is something that you have on your Mac, on your Windows PC, whatever. And then the server validates against a public key if, whatever, when you do SSH, it's fine or not, right? Because it trusts that public key. So we send that public key to the server, we generate the Json Web Token, we sign it with a private key, and then finally the server validates that the Json Web Token it has not been changed or has not been tampered with using the public key that is on the server. So next time that the user logs in, you will get, so the same thing happened, but the next time is a private key on the keychain? It is. So then we just generate the Json Web Token, send it to the server, and it just validates that is a valid token.
So that means that in this case, the Json Web Token is actually not created in the server like before when I called the sign up or the sign in, and it's actually created in the client and then sent to the server.
Correct. And we assume here that a phone can have the secret, in the keychain, and it's protected. This is something that it could be in a browser. It's a different situation, right? Because the browser you have local storage, but there is no really a protection to access local storage, right? But the phone, you have this keychain thing, and you have Touch ID to kind of get the private key from. So it's a good architecture, and I think it's another way of using Json Web Tokens, and that it shows the flexibility and the power of the architecture. This is something that we did available as an open source library. and if you want to kind of amaze your colleagues and do, hey, you can log in with Touch ID, the applause and everything, you can download it and do it in your application. It's also a pod, Cocoa pod. If you do iOS, you know what I'm talking about. And it's on GitHub. Okay. So with that, we have another 15 minutes. I would like to kind of summarize what we learned today. And I think that the main takeaway of this session that we would like you to take is Json Web Tokens or a token-based authentication architecture. It's just a concept. It's an architecture, and it's a long-term kind of decision that pays off in the long term, I want to say. It's a decision that pays off in the long term because it decouples. It takes a little bit more, probably more time to set it up and understanding how it works. It's a simple thing, but you have to, your head has to understand how it works. But in the long term, it's an architecture that will be useful for many things in your systems.
And also, I think that one of the most important aspects of it, one of the most important things is that if we're working, for example, with web apps and HTTP is stateless. It doesn't have state. And when we're having users log in and storing them in the session, what we're doing is converting a stateless protocol into something stateful, because the session is there between requests. And we don't want to make that, because if we have something stateless that depends on something stateful, problems happen. Like what? You have 10 servers. And then a user has to always log in to the same server, because otherwise the session that he had on that server is lost. Or you have to have a centralized point, like a Memcache or a MongoDB or whatever, to have all the sessions centralized in only one place. And that doesn't work that well. With JSON Web Tokens or with tokens in general, the idea is that this is stateless. Why? Because all the user information, all the session information is inside the token, is inside the JSON. And every time you call the server, you put that authorization header with that token. So that means that the session, the user information, is sent from the client to the server on every request. So on every request to whatever server you send it, the server will get the information from the request, and it's not stored anywhere. So that means that the token approach is stateless, just like HTTP, which is like a huge advantage for debugging, for scaling, for having multiple servers, and so on.
So with that, a little plug here. You can get a drone by doing this challenge, and in this URL, you will have to create a JSON Web Token yourself. You can use the tool that we showed, jwt.io. You post that token to a URL that says in this URL, to that URL that you will find in the challenge. And you get a chance to win a drone that I think it's tomorrow, 1 p.m.
Yeah, 1:30. Tomorrow, 1:30 p.m.
So 1:30 p.m. you can get a drone. Also, we have some T-shirts to give away. People who ask questions, intelligent and smart typo detection. You get one, and we are now open to questions. We have another 13 minutes. So, of course, we didn't cover everything about this, and we would like to hear if there is any question. Feel free to raise your hand and just ask. Okay, there is one there.
Do you still have a link to some kind of a session, or can you automatically invalidate the token with the session timeout?
Yeah, that's a great question. So I will repeat the question. So how do you invalidate the tokens, basically? The session has a timeout. Tokens, how do you do the same thing with tokens? The answer is that tokens also have an expiration. One of the properties you can put in the payload is a property that is part of a standard, which is called EXP. And it's basically just a date where the token will expire. When that happens, your API will return a 401 saying the token is expired, and you would have to make the user log in again. There is something that you can do that usually you do with the sessions, which is like sliding expiration. So that as soon as the user is logged in, you want that thing to keep alive, right? So you can do the same with tokens in this way. As soon as the user is there, and you can do a set interval every 5 minutes. Call an endpoint to see if the token is expired or not, and if it's not expired, refresh it with a new one. right? Or you can do it on every HTTP call. If you check if it's expired or not, and then you get a new one. So that's a good way of also implementing sliding expiration. Another question there.
How does this work with non-single page applications?
Okay, another good question. So how this works with non-single page applications? And well, the answer is it's something that you can use on a server side. First of all, if you use, let's say, what is a non-single page application, we will define it as what we've been doing before Angular and everyone came in. What means is you always refresh the page, right? In that case, what happens is that you will have to wait till the page on the client side loads in order to understand if the user is logged in or not. So you can still use it on the server side, but you will need still a cookie to understand if there is something going on the server, because the token cannot be accessible on the server side per se. But one more thing, let me add that something. What you can do, and this is something what we usually do, is you can store the token in the session and then call it, use it to call something else. So again, if you have a regular web app, you can still use this to call other APIs and everything. The only thing is that in a server, you will store the token somewhere that makes sense on the server or in a database if you want.
But another thing regarding that, maybe some other approach would be, instead of actually, so you want to avoid sessions. That's basically the idea if you have a non-single page app as well. And what you could do in that case is, instead of sending the token in the authorization header, you can actually store it in a client-side cookie, and in a cookie HTTP only. So that means that then every time that the user refreshes the page, your server will get the cookie. From the cookie, you can get the token, and from the token, you can get the user information. That way, you still don't have a session. You're using cookies because that's needed when you have a regular web app with refreshes, and you're not sending it in authorization header because it doesn't exist. It's not an API. So that would be, in my opinion, the best way to approach it in that case. So in that case, the session is actually inside a client cookie and not in a server. It's something similar to, if you guys have used Play Framework on Ruby on Rails, they're doing something similar. They're not using a token, but in the cookie they are returning to the client, they are returning their assigned user information. And that signed user information is pretty similar to this approach with the token, where the session is always on the cookie. The only thing you have to take into account is that the cookie's maximum size is 4 kilobytes. So the maximum token and user information is 4 kilobytes in that case.
Yeah, unless you split it somehow.
When you authenticate with a cookie, would you then return the JWT token for the website to access an API?
So in that case, yes, exactly. So you have two options there. So if you want then...
Repeat the question.
Oh, yeah, sorry. So the question that he's asking is, now you have a regular web app and you're returning in that cookie a token. So would you do that if you want to call another API? And for that, what I would say is, if you want to always use the same regular web app, then you just return the token there every time that you use it. Otherwise, if you want to call an external API that does need the Json Web Token, you have two options. Option number one, after the user signs in, you return both the cookie and the token. In that case, if the cookie should be HTTP only, it's safer. Option two, if you want, is just return the cookie, make it non-HTTP only so that you can access the cookie content from JavaScript. And then when you need to call the external API, you just get the cookie from JavaScript, you get the token from inside the cookie, and you call the API. Make sense? Awesome.
Yep.
Out of security concerns, OWASP says you should not store secret data in the local storage.
Yep.
How do you deal with the Json Web Token?
Yeah, that's an excellent question. You got a T-shirt because of that. So everybody went to the booth here. So the question, I would repeat it. So OWASP says that you shouldn't store any secret information in local storage. So what happens with Json Web Tokens? And the short answer is this violates that principle. You are storing a token. If you have an XSS vulnerability in your app, first of all, if you have one, that's the main issue. Someone will be able to get that token, right? When this happens, I like to say that, as everything, it has trade-offs. until browsers start implementing something that makes local storage and more less prone to that type of attack. You have to take care of XSS, because XSS, it will have issues with other things as well. So a good way of approaching this is using Google Caja. It's a project that helps you being kind of XSS protected. So the short answer is you need to be covered on cross-site scripting attacks.
But important on that is that the only difference between local storage is if you have a cookie that is HTTP only, which cannot be accessed from JavaScript. If you have a regular cookie, saving it into a cookie or saving it into local storage is absolutely and exactly the same, because you can get it from JavaScript. And then if somebody goes to your browser and opens the resources tab, like I've shown, they can install it even if it's whatever, cookie HTTP only, regular cookie, local storage. So in the only cases, as Matthias was saying, is for cross-site scripting.
No, because a cookie can also be bound to a specific IP address, and the Json Web Token is just available to all users.
So let me address that. So he says that the cookie is bounded to a specific IP address. Let's make it more concrete. So a cookie is issued by a server, and usually has a domain thing that says which domain can access this cookie, or actually it hints the browser where this cookie, in which domain this cookie can be used. And you can use a full qualified domain like foo.bar.com, or you can say that this cookie is valid for .bar.com. Okay? So if you do that, then the cookie is accessible for any subdomain of bar.com. So the thing is, you can access, so the cookie can be accessed, in this case, you will be able to access the cookie in any way. Sorry, I lost the train of thought. Can you repeat the question?
No, I can continue. So continuing with it, the thing is that local storage, you can also restrict it actually for one particular domain or to one subdomain, so that's similar. And then if you want that token to actually work for only one user, what you can do is the payload, the JSON payload, can have any value. So you could add the IP address of the user in that payload value. The user then won't be able to change it because it's signed with that secret. And then every time you call the API, you will validate it first. Then you will check that it's meant for your application. And then you will check that the IP address from the request matches the IP address from the JWT payload. So you can mimic that behavior with JSON Web Tokens, because basically you can save whatever you want inside there, and it's secured with that secret.
Yeah, that would be a workaround. But another thing I wanted to add, I now remember, my train of thought came back, is that local storage is also protected, and it's actually more restrictive. You can only read something from local storage if you are on that same domain, including subdomain. You cannot read something in local storage that lives in bar.com that was created in foo.bar.com, for instance. So it's more restrictive in that case. It's also bounded to that particular domain. You cannot read that from anywhere. If you were a hacker, I mean, right? Only using cross-site scripting. Okay, any other question?
We have one more.
Two there.
It seems like this token can be stolen easily and be used by someone else. And the server would never know that it's someone else.
I think this is related to what he was saying, and the question is, someone can steal the token, nobody will know if whoever is sending that token is actually whoever thinks, whoever should have been using that token. And yes, so again, if you are vulnerable to cross-site scripting, which is the only way that you will be able to steal that token, then yes. But again, if you look at, there was a huge PR issue with Stack Overflow. I think it was cookies, Stack Overflow. They were using cookies, and this same thing happened to them. If you sit in a coffee shop and with a Wi-Fi, and you were someone using Stack Overflow, I could steal their session because they were using cookies, and they were using HTTP only. So again, if you don't take care of securing your app, we will be vulnerable anyway. The main attack we will find with, or you will have to take care of with local storage is cross-site scripting. But to answer your question, yes, if you steal the token, you can use it.
The only thing that we can add is that a good recommendation for that is to add a short-lived expiration. So that way, even if somebody steals your token, he can use it for 2 minutes or 3 minutes, and then you keep on renewing it. So with that, you make this smaller. So It's not really that much unsafe than cookies. The only other option is if the cookie is HTTP only, it is a little bit more safe, but still you should be aware of cross-site scripting for databases or other problems that would arrive.
Okay. Yeah, another question. Sorry, what was again? Okay, the question is if you can revoke a token. The answer is you need some kind of blacklisting mechanism to do that. And that requires some kind of storage. What you would do is you would have an endpoint that says, first of all, you would need an ID for each token that you generate. Then you will have some storage and some API that can revoke a token. And you would call that endpoint with the ID of the token that you want to revoke, and you would blacklist it. That would be a way. But you have to check if the token is revoked or not, basically.
So unfortunately, we don't have more time, but if you guys have questions, we'll be in Auth0's booth, which is booth number 12, but you can see this logo, and you can come and ask us questions. We'll be there in like 5 minutes. So thank you everybody for coming.